Hey, so welcome to the follow-up to the law of sines. So we got to get the mechanics of the law of sines down, and we know how it works, but it's kind of interesting to take a look at why it works. So this is just a real brief video, and you don't need to take notes or do anything else like that. All I want you to do is just watch and follow along and enjoy the beauty that is the mathematics that unfolds before you. So what we have here is just some generic triangle. It's not a right triangle. It doesn't have to be obtuse or acute or isosceles. It could be any of those, but it doesn't have to be. So this angle is A, and the side opposite A is little a, and this angle is B, and the side opposite B is little b. And all I want to show you is how we develop the law of sines. So first of all, without the law of sines, the only way we can get trigonometry to work is with a right triangle. So what we did is we dropped what's called an altitude straight down from this side, and that forms a right angle. And it also happens to form two right triangles, the one on the left and the one on the right. And I called the length of that altitude smiley face. Could have been any variable. I was just feeling in a good mood. So this side right here is called smiley face. Well, now that we have right triangles, we can use trigonometry. In particular, standing over here at angle A, I could use the sine function. And we see that the sine of angle A is the opposite over the hypotenuse. And I could come over to this right triangle over here, and I could say, well, similarly, the sine of angle B is equal to the opposite over its hypotenuse. And since I'm a member of the shortcut club here, I can solve this for smiley face. Smiley face is equal to B times the sine of angle A. Over here, I could solve this equation for smiley face. And remember, this is the same smiley face in both equations. So that same smiley face equals A times the sine of angle B. Well, gosh, think about this for a second. If B times the sine of A equals smiley face, and A times the sine of B also equals that same smiley face, then those two must equal each other. And if you look at what I have here, I'm going to do a pretty cool move here. Watch what I do. I'm going to divide both sides by AB. Now, why did I divide both sides by AB? Well, I did that because notice that this B makes one with that B, and this A makes one with that A, and what am I left with? Well, I'm left with the sine of angle A over A equals the sine of angle B over B. And that is why the law of sines works.